what we're going to talk about is we're going to talk about how do you solve exponential equations. And the way we solve it is if 3 to the x equals 3 to the 5th, then x has to equal 5. So basically what's going to happen is we're going to get on the left and the right side the same bases, okay, like the 3's. And then what we're going to do is we're going to set those exponents equal to each other. So we've got to get the same bases. Once we get the same bases, we'll be able to set the exponents equal. And so if I look at the very first one I have here, it says 2 to the x equals 8 cubed. Remember what I said, we have to get the same bases. And so that means this number and this number have to be the same. So I need to think about, okay, can I write 8 as a power of 2? So could I write 8 as a power of 2? Yeah, it's 2 what? 2 cubed. So the reason why I picked the 8 is because the 2 is already in simplest terms. I mean, the 2 is the smallest number you have there. And so I know that 8 is 2 to the 3rd power because it's 2 times 2 times 2. So now, if you notice, on the right side, I can even simplify that more because I know that if I have a 3 inside and a 3 outside, what do I do with those 2 3's? Do you remember what we do with those? Multiply them. So it's 2 to what power? The 9th. So if you remember now, I said we had to have the same bases, and then what are we going to do with the exponents? We're going to set them equal. And so basically, this is what you're going to do. You're going to get rid of the 2's. And we know that x then equals 9. So your whole goal, get the same bases, set the exponents equal. Same bases, set the exponents equal. Let's go and look at another one. Okay, so I have 9 to the 2x minus 1 equals 3 to the 6x. So I have to write both the 9 and the 3 as the same base. So can somebody tell me something that I notice about this problem? 3 to the 2nd is what? 9. So what I'm going to do is replace 9 with 3 to the 2nd power. And then here I have 2x minus 1. On the right side, I'm going to leave that as 3 to the 6x. So let's simplify the left side before I set them equal. What do you do with the 2? You distribute it to each. So it's 3 to what power? 4x minus 2. And that equals 3 to the 6x. So now you've got things all simplified. Everything's good on that. And so then what are you going to do now?
4x equals 6x.
Yep, 4x minus 2 equals 6x. And then that's just a basic equation that we need to solve. So to solve that, you're going to subtract 4x from both sides. And I end up getting negative 2 equals 2x. What do you do now? So that, what does x equal? Negative 1. Very good. Not too bad. Same bases, set the exponents equal. So let's look at this one. I want you to try this one for me. Okay, 4 to the 2n minus 1 equals 64. Four to the 2n minus 1 equals 64. That's what you gotta figure out. we're on the right track. Yep, there you go. All right, Emily's going to go ahead and put a per solution on the board. And she actually took a little different route than some of you did. Ugh. Now, some of you still could have gotten this solution, and you might have gotten this solution by doing it the way you did that. Good job. All right, so there you go. Now, I noticed some of you didn't write things in terms of powers of 4, you wrote things in terms of powers of 2, and you could have done that. It's just going to be a little bit more work. Okay, what you could have done, and some of you did this, and I saw that, so don't erase, because I see some of you erasing. The problem you got to is you got to 64, and you're like, oh, okay. 64 is actually a power of 2. It is 2 to the 6th power. And now what you can do is distribute your 2, and you get 4n minus 2 equals 6. Now if you go through and solve that, you end up getting 4n to equal 8. So n equals 2, which is just what was found here. So it's one of those things, you didn't necessarily have to solve it the same way in order to get it correct. This second one that I wrote up here is a little more work than the yellow one. The yellow one's a little quicker. Let's look at another one. Okay, actually I take that back. We're going to look at exponential growth and decay. So this is a formula that you need to get down for me. Y equals A times B to the X. Now a little bit about what are A and B and what is X. A is your initial amount, so that's how much you start with. B is your rate of exponential growth, and X is time. So A times B to the X, that is an exponential growth or decay formula. And so we're going to use that in the next problem. So let's go ahead and see what this is. It says Kristen starts an experiment with 7,500 bacteria cells. So 7,500 is my initial amount. After 4 hours, there are 23,000 cells. Write an exponential function that could be used to model the number of bacteria after X hours if the number of bacteria changes at the same rate. So currently, my formula would be Y equals 7,500 times B to the X. And I don't know what B is. So in order to go ahead and write my equation, I need to find what B is. So let's think about that. I'm going to have to use this little bit of information that they gave me. And what I'm going to do is I'm going to plug in 23,000 for Y. Where am I going to plug the 4 in? For the X. Good. So now, how do you solve that then for B? What's the very first thing you're going to do? Subtract? Divide. Good. Divide by 7,500. So what do you end up getting? We want to go to 4 decimal places. What do we get? And then 0?
0.0667.
Okay, 0.667. Now that's going to equal B to the 4th. And so now I need to solve for B. And so the question is, well, how do you do that? We're going to go ahead and raise each side to the 1/4 power. Or we're going to take the 4th root. So on your calculator, you're going to go ahead and take whatever number, and you can leave it in memory. You don't need to take the 3.0667. You could just go ahead and hit your caret key and then put in parentheses the 1/4 power, or you could go ahead and hit your y to the x key, and then you're going to type in 1/4. And what does that come out to be?
1.323.
Okay, so 1.32, we can now round to 2, so that's what b equals. So I'm going to plug that into my formula here that I started with. I'm going to take this number, and it's going to go right here. So my formula, y equals 7,500 times 1.32 to the x power. No, you cannot combine the 7,500 and the 1.32. Okay, the 1.32 is the only thing that's raised to the x power. So that is going to be your formula.
Don't we know the x then? Is that
No, what they want you to do is they want you to write an exponential function that could be used to model the number of bacteria after x hours. So they want you to do an equation in general, because if you look at this part B, it says how many bacteria cells are expected in the sample after 12 hours. So now what am I going to do in part B? Put 12 in for x. So I'm going to take 7,500. Now if you're doing this on your calculator, depending on the one that you have, you need to be really careful. Okay? Those of you that use the y to the x key, you're going to have to do this first, and then take your answer times 7,500. Those of you that have one of mine, you can do 7,500, put the times sign in, 1.32 caret 12. So you're going to do the 1.32 y to the x.
This one's
Times
your big number.
12, or did not, or 12, type in 12, sorry, hit enter. You take that result times 7,500.
Yeah, I got that.
So what did you end up getting?
209.
209? 0.7? 0.07. So since we're answering bacteria cells, we're going to just start, because we can't have 0.1 of a cell. So we have that many cells. You always round down if you're referring to something like this. So big number. Alrighty. So now the last thing we're going to end with is compound interest. Love it. Love it. Love it. So if I were you, I'd write that formula down. You don't necessarily need to have all the other wording down. A equals P parentheses 1 plus R over N to the NT. A is your final amount. So you could just put final amount for A. Okay? P is your principal, so you don't have to put amount invested. You can just P is the principal. R is the annual interest rate. So R is the rate, biggest thing here, as a decimal. And N is the number of compounding periods each year. And so these are the last few problems we're going to look at for today. And I think you're going to find that this formula is fairly easy. So let's plug in what we know. An investment account pays 4.2% annual interest compounded monthly. If $2,500 is invested in the account, what will be the balance after 15 years? So 4.2%, this is going to be your rate. Compounded monthly, that's going to be number of times compounded each year. 2,500 is going to be what? Your principal, okay? And then 15 years is going to be your time. So now we just need to plug those into the formula. My principal here is 2,500. I now have 1 plus. My rate as a decimal is 0.042. N, it says compounded monthly means how many times a year? 12. And then I've got N times T. Now we have to be careful how we actually type this in on our calculator and how we solve this because a lot of mistakes get made. So all I want you to do right now is I want you to do the parentheses. I want you to take 1 plus 0.042 divided by 12. You're going to get a decimal. It's probably going to be like 1 point and then about 4 decimal places. But I want you to go ahead and get that to 4 decimal places. 1 point what? 0035. Did somebody else get that?
I did.
Okay, now what I want you to do is I want you to take 12 times 15.
I don't know.
180. So then now what we're going to do is we need to calculate this. Now in order to do this, remember we have to do this part first. And then we're going to take our answer times 2,500. So 1.0035 to the 180th power. And then take that answer times 2,500. So 1.0035 to the 180th.
Should it be a decimal?
Yes. And then you're going to take that times 2,500. And when you do that, you get how much? Okay, $4,688.87. Did anybody not get that? Okay. Yes, you got it. Okay? So let's go ahead and look at this one. Find the account balance after 20 years if $100 is placed in an account that pays 1.2% interest, compounded twice a month. So A equals, what's my principal? 100. Okay, and then I've got 1 plus, what's my rate as a decimal? 0.012. What's the number of times compounded per year? 24, good. And so then I'm going to take that times 24 times 20, because it's 20 years. Order of operation states we're going to do parentheses first. So do the parentheses. I want 4 decimal places. What did we get? 005 or 0005?
0.005.
Okay. Now we need to take, which is what? 480. Good. In order to solve this, I need to do this first. And then take your result times $100. Did somebody else get $127.12? So really your $100 isn't making a whole lot of money. I mean, over 20 years you made $27. Woohoo, you made $1 a year. Okay, so anyway, questions on that? All right, your assignment then. Page 464, 9 through 23. Okay, page 464, 9 through 23.